Hello everyone and welcome to another short video on our own devices. I'm Jean Messier and today we're having a look at a unique piece of surveying equipment. Now you'll recall that a few episodes ago we looked at the Mansfield's patent water finder, which its inventor claimed could detect underground water sources by the electromagnetic field they supposedly generate. Now while that particular device was complete bunkum, in principle it was based on a practical instrument called a dip circle, dip compass, dip needle, inclinometer, inclination compass, or dip magnetometer, and that is what I have here. This is an Aqua Magnetic Locator, introduced in the mid-1950s by the Aqua Survey and Instrument Company of Cincinnati, Ohio. And this was designed for use by land surveyors and utility workers to locate buried ferrous objects like water pipes and valves, electrical conduits, manhole covers, and the like. So without further ado, let's have a closer look at this and let me show you how it works. So this device was patented in 1954 by Otmar Peace, William Middendorf Jr., and Carl Every of the aforementioned Aqua Survey and Instrument Company. Now, these gentlemen did not invent the dip circle, which has been around for nearly 500 years. In 1544, Bavarian instrument maker Georg Hartmann first described the tendency of compass needles to dip towards north, a phenomenon we now know is due to the Earth's magnetic field converging at the poles. The closer to the poles you get, the greater the dip angle or magnetic inclination between the needle and the horizon. However, Hartmann was not really interested in why the compass needle dipped and instead set about finding ways of reducing this effect in his instruments. But 3 decades later, in 1581, English instrument maker, hydrographer, and navigator Robert Norman investigated the phenomenon and published the first description of magnetic dip and an instrument to measure it, the dip circle, effectively a magnetic compass turned on its side. Dip circles were soon being used to locate large bodies of magnetic iron ore like magnetite or hematite, and by the 19th century they had been developed into sensitive maritime navigation instruments, particularly for use at higher latitudes near the poles. Using a pre-measured chart or table of magnetic dip values, a navigator could determine how close they were to either pole by how much the dip needle deflected relative to the horizon. Now, by the mid-20th century, dip circles had largely been supplanted as navigational instruments by more sophisticated electronic aids. However, they still saw widespread use in locating ore bodies as well as buried infrastructure like pipes and manhole covers. However, the traditional dip circle design was not well suited to this work. Firstly, the instrument had to be held vertically at eye level for it to be easily readable, and this was not only awkward for the surveyor, but also lifted the instrument above the ground, making it less sensitive. Also, the needle had a habit of spinning around wildly when the instrument was jostled and taking a long time to settle down. The Aqua Magnetic Locator was designed to correct these deficiencies and create a more practical and convenient instrument. Right, so this comes in a nice leather case with a shoulder strap, which allows the surveyor to suspend the instrument just above the ground while surveying a site. If we open up the lid, we can see that the inside used to have gold printing, now largely worn away. Looking at another instrument online in better condition, we can see that this comprised the company name and a big arrow marked north and south, which indicates the proper orientation of the instrument during a survey. Looking down into the instrument, we can see a needle and a dial marked from 70 degrees northwest to 70 degrees northeast, which allows the instrument to be used horizontally as a regular compass for laying out a survey. The scale is also printed with the same directional arrow as the carrying case, the company name, and the patent number. Now you'll recall from before that dip needles are typically mounted in the vertical plane, and this instrument is no exception. Indeed, if we pull this out of its case, we can see that the needle and scale are indeed mounted vertically, and that there is a 45-degree mirror in here that allows us to see them through the top window. This in turn allows the surveyor to suspend the instrument by its strap just above the ground, increasing its sensitivity, while still being able to easily read the dial. When removed from its case, the instrument can also be held by this fold-out handle. Now, as you might expect, to prevent magnetic interference, the body of the instrument is made largely of plastic, likely bakelite, while the metal fittings are made of non-ferromagnetic plated brass. To open this up, we remove these 4 brass screws at the bottom, and the base plate comes off to reveal the angled mirror and the needle and scale assembly, which is retained by these spring clips and slides out as so. And this assembly includes a clever feature to eliminate the aforementioned problem of the needle spinning wildly if the instrument is jostled. Just outside the arc of the needle's rotation is a strip of either copper or aluminium, which is not ferromagnetic and under ordinary circumstances does not interfere with the motion of the needle. However, if the needle moves quickly, then its magnetic field induces in that metallic strip what are known as eddy currents, which, according to Lenz's law, generate their own magnetic field opposed to the original. And this damps out the motion of the needle and prevents it from spinning wildly. This same principle is used in eddy current brakes on high-speed trains as well as in electricity meters, which I plan to cover in a future video. In the meantime, however, you can learn about my ill-fated attempt to use eddy current braking to create a new type of firearms action. Link in the description. Now, according to the instructions that came with this instrument, the proper operating procedure was to walk along parallel north-south paths spaced around 12 to 15 inches apart until the needle dipped from red to black. You then turn 90 degrees to that path and, still keeping the instrument oriented north-south, walked along that perpendicular path until, again, you got a maximum reading. And the intersection of those two paths gave you the location of the buried pipe or valve or manhole cover or whatever you were hunting for. And that is how you use an Aqua Magnetic Locator. Really neat little device. I've seen them here and again at different antique sales and flea markets and always wanted to cover one. And the other day, a good friend of mine, Don, comes up and says, I found this in my house. I don't want it anymore. Maybe you can make some use of it. So thank you very much, Don. Anyway, that's all I have for you today. Thank you so much for watching, and I'll see you in another video where we'll look at yet more fascinating surveying instruments and other devices just like this one. Until then, I'm Jean Mestier from Our Own Devices. Have a great day.